Okay, let's go ahead now and talk about what those exponents mean. You now know how to figure out what they are. You have to use that data. You have to calculate it based on that data by setting up that ratio like we did in our rate law notes. But what we did kind of skip over in those notes was what those exponents actually mean, because what's going to happen on the AP test is you're going to be given rate laws. Like, for example, this rate law, let's say you were given this one, and they were telling you that reactant A had a 0, B had a 1, and C had a 2 as its exponent. And they're going to expect you, without any numbers, okay, without any actual values, to determine what those exponents mean for that reactant in this reaction. So we want to be able to look at those in a non-numerical sense and be able to tell what it's trying to tell us. So you notice in this example, I haven't told you what K is, but it doesn't matter because we're not going to actually calculate. We're going to talk relative. We're going to talk, well, if I change this, what will happen to this type scenario. Also, those numbers up there, that 0, that 1, that 2, those are called orders, okay, orders. And it's not the real sense of the word order that we've learned before and how we use the word order normally. Order in this context means the exponent that is on that reaction. And so what we do is we call the first one, since A here has a 0, we call that 0 order. So if I was speaking to somebody, I would say, well, you can see that A is 0 order. For this one, I would say that B is first order, because it's a 1. And I'm sure you can guess that I'm going to say that C is second order. Now what we need to do is figure out what that means, okay? So if you think about this, let's start with 0 order. If I plugged a concentration into this value of A, okay, so let's say I had a concentration of 0.5. If I take 0.5 and I raise it to the 0 power, what does that come out to be? If you said 1, then you're right. No matter what number I put inside those square brackets, it's going to come out to be 1, which means no matter how much I increase this concentration, even though, say I bring the concentration of A all the way up to 5, if it's 0 order, it's still going to come out to be 1, which means it is going to affect the rate. Not at all. I shouldn't have used that word. It's not going to affect the rate. So if something is 0 order, then what you know about that is that it is not affecting the rate. That should probably be affecting. I don't know. You can fix that, English people. Okay, so it's not affecting the rate. So anything that's 0 order will have no effect on the rate. So if a question gave you the rate law and you had a reactant that was 0 order and it said you're doubling the concentration of A. If I double the concentration of A, nothing's going to happen to the rate of this reaction because doubling it has no effect because we're going to raise it to the power of 0. It's going to come out to be 1. So no matter what I do, I could increase the concentration by 100 times. The rate will not change. That reactant does not affect the rate of a reaction. And we'll learn a lesson coming up later that'll explain why that's the case. But for now, we just need to identify the numbers. All right, now what if it's first order? Okay, what if it's first order? So if it's first order, the exponent is a 1, and obviously that is going to have some sort of effect. And so what you need to know about first order is what I always say is what you do to the rate. You can write this out. What you do to the rate, I'm sorry, I should have said what you do to the concentration will happen to the rate. Okay, so if I double the concentration, that means the rate is going to double. So if I had a concentration of B in one equation and I had figured out what its rate was, if I was to double the concentration of B, the rate is going to double what it was originally. Okay, so if I double the concentration, the rate doubles. If I triple the concentration, remember, what you do to the concentration happens to the rate. So if I triple the concentration, the rate triples. Okay, if I quadruple it, it quadruples. If I multiply times 10, it goes times 10. And that's because the power is 0. Okay, I'm sorry, I'm having a bad day. That's because the power is a 1. So any number raised to the first power is itself, right? And so if you double something, doubling raised to the first power is 2, tripling raised to the first power is 3, etc., etc. So that effect is equal, essentially. If it's first order, whatever you do to the concentration also happens to the rate. Now, let's talk about second order. I need some space here. If we talk about second order, you can envision this like squaring, which essentially is what you've got, right? Because you've got an exponent of a 2. So what happens with second order? So I'll write this out too. For second order, what you do to the concentration will have a squared effect on the rate. Okay, so let's look at some examples of that. So let's say I had one reaction with C. I used a certain concentration of C. I then doubled that concentration. So if I double the concentration, doubling, of course, means times 2, right? 2 squared is 4. So the rate will go to 4 times what it was before. Okay, so again, doubling is like multiplying by 2, and 2 squared is 4. So it will make the concentration go up by 4 times. If I triple the concentration of something that is second order as an exponent of 2, tripling is like saying times 3, and 3 squared, it will be 9 times the original rate. Okay, so those exponents are going to give you those types of values. And obviously, in this rate law, we had 3 different things. But what the questions are going to focus on is usually one of those things. So they'll say, you have this rate law, the concentration of B is doubled from what it was originally. So you look at B, you look at the order of B, and decide what the effect is going to be. If they told you that they changed 2 of them, maybe they're going to tell you they doubled A and they doubled B. Well, we know doubling A has no effect on the rate. We know that doubling B will double the rate. So the answer would be that the rate would also double. So you're going to kind of use those exponents as a way to see what's going to end up happening to the rate without actually using numbers, just using idea of increasing or decreasing those concentrations.